Tim, we're good to go. How do you want me to do it?
Yeah, I guess we can start it off.
Yep.
Okay. Welcome, everybody. This is the DHCP working group meeting. This is the note well. You may have seen it earlier this week. Please take a moment to read it. This covers all of the IPR policies and of the IETF. It's here. And then the really note well is our code of conduct, basically. So please take a moment to read this as well. If you feel like, this is our anti-harassment and other policies. If you feel like something has happened, there's an ombudsman. I'd be happy to introduce you to them. The DHCP working group, I haven't seen anything, but it's always good to be mindful of this and be kind to everyone. It's a real story here. Okay. This is the meeting tips if you're in person or remote. Since we're later in the week, I'm hoping everybody has figured most of this out, but it is here in case you haven't. This is your first one. Note takers. Did I see in the chat that you have offered to take notes for us today?
Yeah.
Perfect. There is a tool for everybody. Tomak, thank you. There's a note-taking tool in the upper corner that we use. Feel free to help them out if you think things are there. Suresh has dropped the actual link right in the chat, so that's perfect. Sorry, everyone, I'm remote this year. In the last 50 IETFs, I've missed 2, and they both happen to be in Bangkok. So it just happened to be the way things fell. So I'm remote, and Bernie is skiing in Austria this week. So he's unfortunately enjoying being retired and is not available for this week. And then so Suresh has kindly agreed to be the interim lead. Thank you, Suresh, for that.
And Tomek too. So Tomek is like, we just happen to be here, so that's cool.
That's perfect. The more the merrier. I need all the help I can get.
The breakfast, like this is the best breakfast thread ever at an IETF meeting, and you're missing that.
What?
Yeah. 2 times in a row.
That's a bummer. I'll have to put it on my list.
This is the best breakfast. No, I'm just kidding. No, I'm just kidding.
All right. So as you enjoy your break, you guys are, this is the last slot of the day, right? This is it. This is ending Thursday for you guys. So enjoy that. So here's our agenda, normal stuff. We actually have a pretty packed agenda today. We have these 5 items. Does anyone have any questions? We're going to cover 8415 biz in a moment, so we'll talk about that. And then we have a presentation from Tommy, Fernando, and Ben and Spencer. Any agenda bashing? All right, I'm just going to move along here.
I think Miria has like an agenda bash probably for the relay stuff, yeah?
Yeah, sorry, I don't have my phone yet. I will log in immediately. I wanted to check out
That's Miria Kulowin for
Miria
people
Kulowin,
following.
Yes. Yeah. What's the status of the relay agent draft? Should we give like a very brief update because we don't have any open issues? So the question is, can we move on?
Yeah, I think Bernie sent an email out about starting working group last call the week after the IETF is the plan for that document. Okay, great. Yeah, so yeah, it's right here. It's the 3rd bullet under, I say 2 working group documents. Apparently I'm struggling to count. There's 2 active ones, the adder, DHCP adder notification, that one's done. Which is why it's really only 2, 8415 biz and the document that we just discussed. And that one, we're going to go to working group last call, I think next week is what Bernie said in his email. And then 8415, I'm going to let Tomek talk about. Go ahead, buddy.
Okay, Tomek Mrugowski, ISC. So since Dublin, there were 3 versions, 07, 08, 09. We addressed comments from DNS Directorate, from Jimmy Reed, and from Jenard, so from Dale Worley. So thanks a lot for the comments. So briefly, we added a reference to AI, LL, and added a note that other AI types might appear. We simplified stateless intro text, clarified destination port, updated the DOID and enterprise ID. So for historical reasons, it was using Cisco. Now it's using the number specifically designed for the documentation purposes. And we did a bunch of wordsmithing. So, and I'm afraid I discovered one very little thing to do. So there's a typo in one of the group name. So, but this is so small that RFC editor can take handle of this. So, and that's basically it.
So Eric,
Thank you.
just a suggestion, right? Like, so if you want to do it instead of RFC editor, can you attach a note for them after the IESG review? So for the this is for the typo. Okay.
Or either you fix it on your own and you submit. That's way easier. Resubmit now with the typo fixed.
Okay, so in that case, 011 coming up.
Okay. Thanks. I saw your note. I'll approve that MR when it comes in, or PR. No worries. All right.
So Eric,
Thank you
so
for
this
that
is on the next available telechat, right? Okay. Far away. May, right? Like May sometime. Yeah.
May the 8th.
Damn it!
Hey everyone, Tommy Jensen. We're going to talk about option concatenation. Fresh new topic. Next slide, please.
Do you want
Oh,
control? Yeah.
sorry. All right, so in 2005, RFC 3396 defined how to concatenate DHCP options. That way you could have larger option data than an option could contain. This is wonderful. It defined two different categories as options that are concatenation requiring and options that are non-concatenation requiring, which is reasonable. Unfortunately, the way the document is structured is that it ends up requiring concatenation for all types by giving this text, so that clients have to say, if they see duplicates, even if they are non-concatenating, you just need to be defensive and concatenate them anyway. And this doesn't make a lot of sense in practice. For these three major scenarios that we've observed where options are supposed to be lists, maybe you can concatenate lists together. For single items with fixed length, that's usually a horrible idea, because if they're both valid by themselves, they're invalid together. And then there's options that are simply non-zero length. Who knows, without parsing them or having option-specific awareness, if they make sense separately, if they make sense together, one or the other. So in reality today, most DHCP implementations, or at least the couple of providers I've spoken with, have a strict list of things that are not the full set of concatenation requiring that they will stitch together when they see duplicates, and otherwise they just pick a valid option. Some first, some last, but just pick one of them that is legitimate, which is a good way to keep yourself online, because in a fun example we saw, a network was providing two different lease times, which if you merge two 4-byte lease times to get an 8-byte number, you're either going to hold on to address for a very long time or end up with connectivity issues. So we're technically out of spec, as is everyone else, which is unfortunate when you have new maintainers or developers coming into existing stacks, or heaven forbid, someone's creating a new one, that the RFCs do not describe how things are really supposed to work, let alone how they work in real life. So this draft that Milan and I are proposing will update 3396 and just specify, look, if the option is defined as concatenation requiring, go ahead. Otherwise, here are some suggestions about ways you could react and the implications thereof. We're not trying to be normative about, all right, and therefore don't ever do this because maybe it makes sense, but breaking down, these categories I went through earlier to kind of give hints to the implementer of what they're getting themselves into if they decide to merge or just to take one or straight up call it a protocol error. So we did a -01 in response to some feedback to make this clearer, because we're not actually trying to invent new behavior. We're trying to describe the reality of behavior 20 years after the RFC was published. And yeah, we're not trying to rev DHCP, we promise. So we think that this document should be adopted here for what I hope are straightforward reasons, because we want to correct the record for new arrivals who read RFCs but do not track the IETF and maybe don't have the benefit of being well connected to major implementations to understand what's actually happening. And noting that even though IPv4 itself is not supposed to be revved in the IETF, we are still creating DHCP options, the most recent that I'm aware of being at the end of 2023 in RFC 9462. So as options get created as option concatenating or non-option concatenating, it would be great if this guidance on how to do concatenation was up to date. So with that said, open to questions, feedback. Do you think it belongs here?
David Lamparter. I apologize, but I'm about to make that year number on your slide 2025 because I'm doing a new DHCP option for v4. And I almost accidentally fell into this trap because I wasn't aware of it while outlining the options. So I would very much appreciate the working group adopting this. And yeah, that's it.
Thank you. Yeah, definitely a good example that, you know, we're still working on it. I don't know who's. Oh, Tomek.
Okay, yeah. Tomek Mrugowski, IC. So this is, you are talking about the DHCP v4 only, right?
Correct. Yeah, concatenation isn't defined for DHCP v6 that I'm aware
Yeah,
of.
yeah. We have 16 bits long options, so we don't need it.
Until 2028 when we do a 1 megabyte option. But we'll cross that bridge when we get there. Robin?
Thanks, Tommy.
So, Tim, what do you want to kind of kick off an adoption call at some point on this?
Yeah, it sounds like, you know, I mean, obviously in the room, it sounds like there's interest. No one's opposed. So I don't, you know, I think Bernie was a little less warm on this one, but I think it's a little late. But at the same time, I also think it's worth clarifying. So my instinct is, yeah, to go ahead and have an adoption call. We'll do that on the mailing list as per the norm.
Yeah, Ekwi, would you send a review to the list as well, just in case?
Yep.
Thank you. Anybody else wants to review this document? Tom, how about you review this document? It's a small room. Like, okay, yeah, thank you. Bing, Sheng, can you review this document? Okay, Sheng volunteered for.
Voluntold.
Yeah.
Fernando, you're up next if you're online. I think I saw you on there. Yeah, there you are.
Fernando.
Can you hear me?
Yep.
Oh, okay, that's good. So good morning. Well, good evening, whatever that is, to everyone.
I think whatever that is makes sense because there's people everywhere. So yeah.
Yeah, so it's like early morning for me here. So I'm Fernando Gont. I will be presenting the document, has a long name, a method for generating semantically opaque IPv6 interface identifiers with the HCP version 6. Disclaimer, the title wasn't really mine. I wasn't the one that said the title. Actually, this title was migrated from a similar document that was published by the 6-man working group. Okay. Next slide, please.
I think you should have control, Fernando, of the slides.
Oh, let's see.
Yeah, it did.
Oh,
move.
that's great.
Yeah.
That's great. So actually it happened twice. It looks, there you go. So motivation for this document in one single slide. essentially during the last few years, there's a lot of work that we did on the security and privacy implications of predictable transient numeric identifiers. These are the kind of identifiers, short version of the story, the kind of temporary identifiers that normally you employ in different protocols, whether that's port numbers, interface identifiers, fragment identification numbers, in IPv4 or IPv6. There was a lot of work in this area. We ended up publishing 3 RFCs. 9414 and 9415 were a product of the Internet Research Task Force, and 9416 was a product of the IETF. 9416 is a standard structure. Yeah, I believe it was like BCP document that updates, that is part of BCP 72, the document with recommendations for writing security considerations in RFCs, and essentially introduce requirements, guidance for transient numeric identifiers. It says a number of things. I'm not going to summarize the entire document here, but the 3 main, let's say, pieces of advice is that one, you should specify the interoperability requirement of your transient numeric identifiers. What are the properties that you need in those identifiers? Because otherwise the protocol will break in a way. Second, that you should do a threat assessment of what are the security and privacy implications of those identifiers. And number 3, which is the one that I'm listing in this slide, is that you should recommend an algorithm for generating the interface the numeric identifiers that are specified in your document. Short version of the story, and that is in RFC 9414. Experience and past experiences indicate that whenever you have a protocol specification that doesn't have recommendations on how to generate numeric identifiers, that results in flawed specifications. The implementations, generate identifiers in a bad way. That's why, short version of the story, why we ended up with this advice. Now, the DHCP assigned IPv6 addresses, or in particular, the interface IDs that, you generate with the DHCP version 6 are essentially just one type of these identifiers. Normally, in order to have a proper recommendation, as it's recommended in 9416, either you have to have the normative language in the in your own specification. In this case would be 84 or have a normal. Now, I ended
Remember,
up
we lost your audio for a second.
79.
Can you just repeat what you said, like for the last minute?
Yeah. Sorry. I was saying that IPv6 addresses, interface IDs, are essentially one type of these, transient numeric identifier. Okay, and according to 9416, a protocol specification that recommends these identifiers should have a recommended algorithm for generating them. How can you do that? Well, you can embed the recommendation in the protocol spec itself, or you can have a normative reference elsewhere. Obviously. Now, I send an individual submission to the RFC editor 7943, which is and obviously it's individual submission, so it's like an informative document with an algorithm on how to generate interface IDs with IPv6. Now, obviously, that's not a document that can be used, for a normative reference. So the goal of this document is essentially produce a standard struct version of the same document. That's the short version of the story. Now, short recap. What happens with IPv6 addresses or interface IDs? Well, if you generate, the DHCP v6 assign addresses or interface IDs, that can lead to 2 different things. On the one hand, security and privacy implications, that's discussed at length in 7721. In fact, that's referenced in 8415 bis, if I remember correctly. Then, on the other hand, when it comes to interoperability or operational implications, Well, that depends on what the expectations or the requirements are. Obviously, the base requirement is the addresses need to be unique, obviously, but then there's generally an expectation, other things set aside, that DHCP version 6 results in stable addresses, because if the addresses change for operational reasons, that's not super nice. Now, when it comes to what could possibly go wrong with this generation of IPv6, the IPv6 assigned addresses, interface IDs, there's a number of implementations that in fact are already known to do this, generate the IPv6 addresses in a predictable way, like with an incremental sequence. And not just that, in a lot of cases they use a small address pool size. Okay, so they don't even use the address space that they have. This is also at odds with, I believe, with RFC 7934, which essentially tries to avoid implementations enforcing limits on how many addresses they can assign. Obviously, an implementation that selects or employs an address pool that is small, obviously that's going to introduce a constraint for how many addresses it can assign. I believe so. This document covers interface identifiers, but I believe the same argument should probably be made about the when a DHCP v6 implementation generates like prefixes to for prefix delegation. Okay, so what this document does, as it's a standard struct version of 7943, which was published as informational. It generates, IPv6 interface IDs. This is super similar to 7217 from the Slack world. The resulting addresses, they don't result in address patterns. They are stable within each network, but they change, if as you move from one network to another. And one thing that is nice, I believe, the algorithm doesn't require stable storage, because it will use an expression, an algorithmic expression to generate these identifiers. That means that even if an implementation, for example, didn't have stable storage, or there was problem with stable storage, after a reboot, the implementation would still be able to generate the same IDs, even without stable storage. Something that is also nice is that if you wanted to have, like, for example, two DHCP servers, for failover, if the secret key that is employed, the implementation is the same, the secret key is the same, both servers will generate the same interface identifiers without even the need to having to synchronize the list databases. So, quick recap of what the algorithm is about. The main part of the algorithm is this expression, this RID. RID is essentially like a randomized identifier that is essentially computed by running a hash function. We recommend SHA-256, but the impression does the algorithm doesn't matter that much. That you compute over all of these parameters, which most of them are straightforward. The only one that I will just mention is the counter that we will use if you find that an address is inappropriate, like, for example, it has been marked as declined and so on. And the secret key obviously is self-explanatory. It's like, unknown to the attacker. So this is like the core part of the algorithm, okay? Now, when you put this expression in context, the idea is that whenever you want to, list an address, first of all, you compute that RID that we saw in the previous slide. Second, you generate the address with this expression. As you could probably see, this is just in those cases where you are using a smaller pool as opposed to just the entire /64. Okay, this is if you want to use like pools of some size, but not the entire prefix. Then you compare the resulting address with the the corresponding interface ID with the reserved interface IDs. If what you computed is unacceptable, you simply increment counter and go back to step one. Okay. Now, if everything is fine, what you do is you check if the address is unavailable or declined. For example, the address is already in use or it has been marked as declined. In that case, you do the same thing. You increment counter, go back to step one. And, step 5, if everything went well, that's an address that you can lease to a client. So that's it from my side. So from my side, it is like, comments, questions, and if the document and if the working group believes that it's a useful document.
Thanks, Fernando. Eric?
So Eric Vink, no word at all here. Fernando, do you remember why RSC 7953, like the original one, was independent stream rather than IETF stream?
I will let the chairs answer that one. I can tell you my take about that. So the document was adopted as a working group document at the time. Okay. There was an objection that was raised on the mailing list, like complaints are something I don't like about the document. I responded to those comments. I believe they were addressed. This was like something years ago. The document eventually got unadopted, if there's a term for that. I don't. If you ask me, I don't really have like an answer myself. So that's like that's my take. But I might be biased, so I don't want to say that is what it happened.
Okay. Thank you. I should check this. So, do you think this should be applicable as well for prefix delegation?
I believe that yes. So the document at this version, it just covers the the interface IDs, because obviously that's the obvious thing. It's migrating 7217 to this. That's like what it is, like the same thing. But if you ask me, yes, and actually you raise a super very important point, because if this kind of thing was used for generating the prefixes, that might help prefix stability, even in those cases where an implementation doesn't have stable storage, for example. And this should help prevent the flash renumbering scenarios that we have been discussing for ages now, like as in V6 Ops. So your answer to your question, 100% yes.
Okay, thank you.
So yeah, Lorenzo Coliti, I think basically we're saying, well, we didn't like it last time, but maybe we've changed our minds, because this is essentially the same as we published as the IC, which is, people can change their minds. That's fine. But of course, the same the same concerns that were raised can be raised again. There's a few concerns here. Number one, like this really doesn't scale down to small pool sizes, right? Because you lose the entropy and you very quickly lose the property that you want to preserve here, which is the, kind of like deterministic ability to generate the addresses based on only on the secret key, right? So if we wanted to propose this, we would have to at least figure out for what pool sizes we can actually do this. If you're talking about something like PD, I'm pretty sure that like we don't have enough entropy in the typical prefix sizes, typical prefix pool sizes used today for this to be actually reliable and actually stateless. The other big problem, of course, is, as the ISG noted, is that decline, basically, in the presence of decline and DAD, this kind of falls over. And again, it loses a lot of the properties that, for example, it loses the stateless property that like multiple servers can like agree on the same IP address. It loses the property that you can do this without stable storage, because if let's say I'm a DHCP server, I hand out a lease to some client and that client declines. Now I have to remember that, because if I reboot and the client asks me again for a renew, what am I going to do? Right? I'm going to calculate the number that I would have given it. It's not going to match. I don't have a lease entry for it. What am I going to do? Am I going to accept it? And in that case, what do? Do I accept everything? That seems like problematic for a DHCP server, right? Because then I can just, like, clients can like create new leases. It just seems like very sort of shaky, right? So I think these would have to be like substantially addressed in the document from an operational perspective. I mean, yeah, you have an algorithm that can generate IIDs. That's good. But then all of these cases need to be, I think, addressed.
Yeah, Suresh Krishnan. So I'm the AD who wrote that IESG note. So I just want to make sure that I clarify it. So one of the things, like Fernando, I think we had this discussion. I think you, me, and Bernie, maybe Tim. I don't know if you're involved at that point or not. But so the discussion was that like the DAD failure was certainly one thing, right? Like the client does a DAD and the address fails for some reason. there's no recovery mechanism. And I'm sure, Fernando, you can probably come up with a recovery mechanism, right? Maybe increment the counter and try again if you get a decline. But I think it needs to get added for a standard strike document, right? Like commenting as nobody right now, right? Like, but I think that would be a potential way out of it, right? Like, because right now, when unacceptable address is generated, right? Like, so let's say it's coming from a reserved range, right, of IIDs, right? You increment the counter and try again. So maybe like if you get a client decline, you could probably do the same thing. I'm just giving you a suggestion if you want to do it, right?
That's in the document already. And
No,
actually, that is in the document. So if you get
no, but that's
a
not in
decline,
the original document, right? Like that's the whole point, like of
I will check. I believe it was, but at least in the current version of the document, it is. Now, another thing to mention here is like two things. At the end of the day, you need clients to cooperate anyway, because no matter what the algorithm that you use, if you have a client that essentially sends like every single decline for every single address in the address pool, you are screwed too. That's one thing. The other thing is that besides this document itself, which one might like it better or not, there's a recommendation in BCP 72 that you need to generate addresses in a way that is not predictable. So I wonder myself if you have an implementation that say you was using an address pool of 1K that made this algorithm unusable, so to speak, how would that comply with 9416?
Mm-hmm. Yeah, I just searched through the document, Fernando, for decline. I didn't find it, but I'll take a closer
It's
look.
misspelled.
It's misspelled. Okay.
Declined, and that's why you didn't find it. But like I think so it does. It only says, for example, if it's declined. So I guess what I'm getting at is that there's a bunch of So I think that where this really falls over is that like DHCP6 is kind of like it's stateful, right? It's fundamentally stateful. It has this concept of a least database. And we have a document that basically describes a mechanism for generating the IP addresses. Good. And then we're like, oh, but it now makes it like stateless, which it doesn't really. So I think if we remove that claim, maybe this would be sort of a little bit easier. Alternatively, if we want to maintain that claim, we must say, okay, here's the circumstances in which that claim holds. Prefix, like pool size really big enough, no declines, or like I don't see, to be honest, how you can actually make it stateless, because in the presence of a decline, you need stable storage. But in general, if we want to do this, we have to write operational guidance, which is not there.
Just a clarification on my side. So the comment about being, so the document doesn't pretend, or at least in my model, my mental model. So it's not that the document pretends to be stateless in the sense that no, you don't need a least database anymore. What we say is that you do things as you always do things. Now, if you were to experience a scenario where you lost, for example, the least database, this might help, but it's not it's not an argument about like, yeah, this is a stateless. Forget about like keeping state. This is not what the document means. It might not be clear, but if that's the case, I can tweak the document so that is made clear.
The other thing that I think I have a sense of deja vu, but I remember maybe saying this at the mic at some point. I have another proposal. Let's do random. We have a least database anyway. Let's just do random. And like a bunch of implementation already support this. We should say, please randomize the IP addresses unless you have a better algorithm. And that's it. And that's like, 2 lines with boilerplate, and then we move on, right? That I have a counter proposal.
And that is sensible too. And in fact, that, the 8415 base is not, done yet. That could definitely be added. Recommendation, do random, and or if not, that's fine, even if it's in a different document. I guess that there are trade-offs. I don't know if it's the same, like if you do but if random interface ID is acceptable, go for it. Like this is one algorithm. I believe that it has better properties, but people might disagree.
Yeah, just real quick to comment on the 8415 part of this. That document, that ship has sailed. So this would just be a standalone thing at this point. Go ahead, come on.
Okay, so Tomek Mrugalski, ISC. In Kia, we have several allocation strategies implemented. This is configurable. If we are talking about hey, this is yet another way how the server can be configured to come up with addresses, I'm perfectly fine. But if it pushes some requirements that, hey, you are not allowed to store the leases, this is like big no-no. So
No, the document doesn't argue that. So there's no question about like the lease database. You keep doing sync in exactly
okay,
the
good.
same way. Yeah, yeah.
I think, Fernando, like I don't think there's anything in the document. I think it might be because you said, hey, there's no need for stable storage for any of this. I think that's kind of probably what triggered like both Lorenzo and Tomek's discussion.
Yes.
So, and I just wanted to make a point that Tim said, like the 8415 bis has sailed. It's not just that 8415 bis is just moving 8415 to internet standard, which means that like unless we have like multiple implementations existing for like 20 years in the past using a time machine, we are not like putting it in there, right? Like, so it's the wrong thing to do, because it's pretty much a track change, right? Like our maturity track change for 8415.
Yeah.
So this is not open for any new features to come in. If there's some unused feature, it can go out, which is what happened, but there's really no features getting in or new recommendations getting in.
David Lamparter. The only scenario where I see any use in this is if I have 2 or more DHCP servers or servers being relayed onto the same link from different vendors, and I want them to behave the same way to generate the same identifier for the client. If I only have one DHCP server or multiple servers of the same vendor, they can just do this as their policy. Like Tomek explained, Kia already has various strategies for allocating addresses, and then we don't need this. So I'm not sure if this benefit is worth it for the amount of work we're putting in here. Maybe instead, this should just be, here is one particularly good version of generating the addresses, picking them. This might be something you want to implement in your DHCP server because it's maybe a little bit better than the other ones, and leave it at that.
Yeah, Lorenzo, clearly, I think even saying it's good would require sort of like documenting why it's good. I think the other thing I just wanted to note, 8415, I didn't look at BIS, but presumably text is still there. 8415 already says that you should not generate predictable interface identifiers. So that text is already there, and you could argue that this is not like one of the main claims here is that other than there's an RFC that says, protocols should say how to generate it. It kind of does. It says don't make them predictable. That sort of, so again, like not clear why we sort of need something like this, especially since we have an IC stream, like RFC already written. Like it's just like
So based on the argument is essentially the entire document is in 9414. If you look at protocols of every single layer, every single time a protocol has not had a recommendation and a standard way of doing things, they have generated the identifiers in a bad way. That's look at TCP, look at IP, look at NTP, every single protocol that you can think of. There's also there's the recommendation of, don't make them predictable now for an implementer, which is what happened with every single identifier in the stack. Okay, what does that mean? Okay, I'm game. What does that mean? That's the advice, that one needs to convey. Same thing with the address pools. You might have an implementation that say, okay, I will generate random, but they use a pool of 100, 100 addresses, so to speak. There has to be that's not going to be good enough. You should use pools of at least X size or whatever that is.
Okay.
Document doesn't have any text about pool sizes, does it?
A recommendation? No.
Yeah. So, I mean, I think if somebody reads should not be predictable, they're like, well, I'll just randomize it. That seems fairly likely to happen, but yeah.
Okay. Thanks, Fernando. I think, it sounds like the working group's not quite ready to adopt this as is. There's some things to think about with this document. Yeah. Basically what I heard was, maybe consider making this an option to tell people how to write algorithms. This is I don't want to say standardized, but this is a way you could go about doing this. Seems to be where people are headed with this. Anything more formal or requiring servers to do these types of things did not seem to be a working group of working group interest is how I would put that. So I think more work needs to be done. I don't think we're quite ready to adopt as a working group. I think we can continue the discussion on the mailing list. Okay.
Thanks,
Awesome.
Fernando. Thank you.
All right. All right. Ben and Spencer, I know you're both online. Ben, I'm going to give you control of the slides.
Yep, that sounds good. Can you guys hear me okay?
All right.
Yep.
Wonderful.
And your slide blends with the Meet Echo background, like it's almost seamless.
Sure. Yeah, I chose the background color just because it's 6 a.m. here, so wanted to go with the dark background. Didn't want to blind myself too early in the morning. All right, Spencer, ready whenever you are.
Yeah. Hi, everyone. I'm Spencer Kuchar. I'm here with Ben. We're talking on behalf of the University of New Hampshire Interoperability Lab, and we're here to talk about some results of a virtual plug fest we did a couple weeks ago.
All right. Ooh. Background. All right. So a little bit of background information about the event and sort of why we're doing this. So the UNH IOL has been helping to develop some updated specs, specifications around DHCP, both conformance and interop, for use with the V6 Forms Ready Logo program, and also for the USG V6 program from NIST for US federal agencies. The current DHCP specs from the Ready Logo program still point at 3315 and friends. So obviously we'll want to try and update those. The draft test specifications that we've been working on over the last few months, years, will now reference the updated 8415 biz, where that's all the way through. Both will be posted for public comment, the test specifications, that is, at the Ready Logos website very shortly. They're not, the updated ones aren't up there yet, but they will be soon. So the purpose of the event was basically just to test various client server and relay implementations against each other for a couple of different reasons. One of which being just proof of concept testing for our current draft interop spec. We also wanted to try and identify some implementations that labs could actually use for building interop test beds, and then just a general information gathering exercise to see how well the HTTP6 enabled devices implement 8415 as written. So for the event, we collected results from 4 different sets of client server and relay sort of pairings over the course of about a week. And I should also note here that the results that we're about to share here are anonymized, obviously. The implementations that we selected, well, we actually didn't select them. They were based on registration from different vendors for different implementations. And we'll go into a little bit about some of the results that we collected and some fun things that we found out. So, here we go.
Yeah, so we basically designed test cases based off of what we thought were reasonable features from the newest draft. I think most of them are pretty straightforward reading the rows, but we can elaborate if they're not. Some of the interesting things we found were, I guess, unsurprisingly, a lack of support for some certain features. So 3 out of 4 of the clients we tested didn't do PD, as you can see all by the yellow cells in this table. 3 out of 4 of them didn't send confirm messages. 3 out of 4 didn't support reconfigure exchanges, and none of them supported rapid commit. And then 1 out of 4 didn't support release exchanges. As far as other results go on this table, 3 to 4 of them did not transmit decline messages under any circumstances. So that was interesting, at least for us to see. 2 of the clients did not renew at T1 and did not rebind to T2. We had 2 clients that did not properly respect, I guess, for lack of a better term, the no address available status code and advertised messages, and didn't ignore them, proceeded to request. We had 1 client that used leases after the lifetime expired, the valid lifetime. and we had, sorry, one sec. Yeah, and then that's essentially, and for DNS test cases, we also had 2 clients that didn't properly get new DNS servers from renew or rebind messages and continue to use the old one. So if you don't mind going next slide, Ben. This is just sort of a summary of what it basically just said. Same information kind of on the table. So these are the interesting results, I guess, we got from the client perspective. If you want to go next to server, please.
Spencer, can I ask a quick question about that? For the T1 and T2 test, did you guys actually do different T1 and T2s, like, and merge them, or was that just generic, just on one IAD for the T1 and T2? So 8415 allowed, if people have separate T1 and T2s, that you choose so you don't make stateful issues between PD and IANA. I assume because you didn't get a whole lot of IAPD, you didn't end up testing that, and that's really just devices doing bad T1 and T2s.
Correct. Yeah, we actually didn't run those test cases with multiple IAs in any circumstance.
Okay, thanks.
So the server statistics are, I guess, a little less interesting just because we have less capability for, less test cases, I suppose. So the results here are, we have 2 servers that didn't do PD, and then 2 that were not able to test with clients due to interop limitations. 3 of them didn't send configures, and 1 out of 4 of them did not do rapid commit. And as far as actual failure behavior, we saw 1 server that wouldn't respond to rebind messages under any circumstances. And then we just had 1 server that wouldn't properly send no address available. But as far as server results, that's essentially the extent of what we saw. If you want to go next slide, please.
Out of curiosity, if you put server D on client B, what happens? Like, client B can't renew and server D can't rebind, and so it doesn't work?
Sorry, could you repeat that?
So, like, client B couldn't renew, and server D couldn't rebind. So if you put those 2 together, then it just doesn't work.
Correct. We didn't actually, that's the assumption. We didn't test those. So A always lines up with A in our table. We didn't do any mixing of letters in that case. But yeah, so I guess theoretically we would expect nothing to happen, but we didn't practically test that. All right, and Relay Agent, we tested this with all the different message types that we could, but the results were all the same. So there was for the Relay Agents we tested, there was none that weren't able to propagate the messages properly between links. But we did see some interesting behavior that Ben will get into in the next slides.
Yeah, so just overall interesting discoveries that we made, not specific to any one test case. One having to do with the Relay Agent behavior that Spencer just alluded to, and then some interesting thing, just generally stuff with T1 and T2. This is probably the most fun one. We did notice an issue with one of the Relay Agents that we tested with, where when we set up relay destinations to use global unicast, and here's a demonstration or like sort of example topology that we were using for that test case for the single relay setup. That relay in particular would use its one of its global source addresses from the first network that the client is attached to when forwarding messages to the server on the other network, which kind of messed some stuff up as far as source address selection and like how the server was actually supposed to know to respond back to the relay agent, which just for testing purposes required us to set up some fun routes, set up a static route just so the server would know how to talk back to the relay. This last bullet point, as far as we could tell, and I'm more than happy to be corrected on this, we didn't find any text in section 19, the relay agent specification of the of 8415 biz on source address selection for relay forward messages. Not to say that this is a suggestion that any text should be added necessarily. Just was a point out of we saw this weird thing, and we were looking for text that says no, you're not supposed to do that. We couldn't find anything as far as we looked. So one interesting behavior. And then generally stuff with T1 and T2 timers, as we talked about with client results, half the client implementations we tested sort of had their own, like chose their own values for T1 and T2, which sent renew messages and rebind messages, like not not specifically when the server told them to. One client implementation actually didn't send any renew messages at all, as Spencer pointed out. One server implementation didn't directly support setting T1, T2 values. This is to say, I mean, a lot of the implementations we tested actually would generally speaking infer T1 and T2 based on the valid inferred lifetimes that were associated with that address pool, which makes sense. And also noteworthy that no servers actually supported setting T1 and T2 values to 0, to leave them unspecified. And yeah, that's for the most part all the results that we found. So sort of next steps as far as testing goes is we have planned updates to the interoperability specification that we used during the event, just trying to account for scenarios that we ran into and other interesting use cases. Building more stable interop test beds that can be actually used for certification testing based on, again, some of the results we collected, and just generally speaking, a lot more testing. So that's about all we had. Open up to questions and comments from the group.
David Lamparter. If you do DHCPv6 PD, someone needs to take care of routing that actual prefix. As a routing person, we don't test that because it's a DHCP thing. It looks like you didn't test that because it's a routing thing. Maybe we both should be testing that. The only situation where I've seen this work with any kind of reliability is if a relay is involved and the relay is in fact co-located with the router and they're integrated with each other. I would really appreciate data if you can do that on whether this actually works correctly in various combinations or not. I understand that this is slightly outside this, like leaving the scope of things, but it is pretty important, I think.
Yeah, David, just to answer that, the only place I've seen that work is definitely DOCSIS, and where it's rolled into the relay agent routing mechanisms of the head end. It works in BRASs too, but on the ISP side is the only time I've ever seen this work. In the enterprises, it's the Wild West. Ben and Spencer, the only other question I had was you talked a little bit about DNS options. Were there other options you tested, or was it really just you just chose DNS because it's obviously a very critical option? Wasn't sure what other types of option testing you did.
No, basically the last thing you said, we basically just tested DNS because of, its criticality, but okay. I guess.
Okay. Yeah, that might be something for you guys to think about in the future, is what options are out there, how they're interop. We often hear complaints about option support from different vendors, but it sounds like you got enough problems. You discovered enough problems during this. Yeah, I mean, just in general, I'd like to thank you guys for doing this. This is really helpful for us to see where there are issues, for sure.
Yeah, of course. And if there's any interest in, if anybody has any suggestions on other options that folks would like to see tested, then more than happy to hear about it. So if anyone wants to drop us a line on the mailer or otherwise, then appreciate it.
Yeah. For working group next steps, I think we would love to see the interop spec just as a group. Just please, when you guys have that available, just put it out there. It's great for people to see the interop test cases, and as you mentioned, give feedback. It helps everybody. So we can do that. Awesome. Thanks, guys.
Thank you.
Thank you.
Suresh, I think that's all. That's all I have.
Sounds good. Thank you. And thanks a lot, Tim, for staying up in spite of this unfriendly time. But hey, time zones are time zones. I think if you come to the next plenary and abolish time zones, that we can take care of that. But yeah, complain to the IESG about it. But yeah.
Yeah. Awesome.
we like you know the Swatch watch which had this like totally new time zone, like they came up, it's called beat time or something. Look up Swatch time. So it's like this random time zone they came up with. All the Swatch watches in the world will be on the time zone, so you could always tell them what time Swatch time you need to meet at. So yeah, interesting stupid thing. Yeah, it's beats. Yeah, exactly. Oh, let's meet at 1,000 beats. It's almost as interesting as a French decimal time, which is another fascinating topic you should look at. The French decided they'll divide the day into 10 hours, and that works like really well. I have. Excellent. Tim, you can sleep. We give you permission to go back to sleep and avoid our snark. Thank you very much, all. Anybody following remotely, have a nice day. Thanks, Tomek, for helping out. And you're looking good. You lost a lot of weight.
Yeah.
What is it? Diet or exercise?
Both.
Are you still traveling a bit?
Yeah. Now my daughter is 3.5. So she's here for like 2 weeks with me.
She's here?
She was here.